There we go. Okay, so the entry-level examples are very, very simple. And these are things which, if you are an entry-level or maybe even intermediate Python programmer, somebody who's thrown together a couple of scripts, written a little bit of glue code, things that you can do just to get a better sense of how your code works. The very simplest one is to look into the sys module. There's a lot of really cool things in the sys module that can really help you either debug your code, figure out how it's running, figure out the conditions under which it's running, and or even trace the code, help you debug the code. I should also add that the GC module is a very interesting module for the same purpose. But I mean, just briefly, we can talk about a couple of things in the sys module. There's a bunch of stuff in there that you probably won't really care about. Display hook and accept hook. These are hooks for when you need to display something to the screen or when an exception is raised. This one actually, I actually had to use, executable. So I had a script that was running on Windows, and there were Python installations all over the place. There was one that was installed as part of the package that this application came in. There was one that was installed by me, downloading from python.org. And I needed to figure out which of these was actually being used, because they were all different versions, too. So sys.executable, it'll tell you which is the actual executable that is behind the interpreter that you're currently using. Very simple thing, but you'd wonder, you can think that this would actually be very useful for you to know. Now, it may not be useful in the course of writing an actual large application, but if you're debugging that application, you might want to know what's going on. Similarly, I had somebody come to me and they were trying to use Jython. And for some reason, their imports were failing. And so the first thing I did was I typed sys.executable. And it turns out that in Eclipse, where they were writing and running their code, it was hitting the system Python instead of hitting the Jython.jar. And the issue was mainly just retargeted so that it runs in Jython instead of running in CPython, and then everything worked. But this guy was having a lot of issues because everything indicated that just importing this module should just work. And he couldn't figure out what he was doing wrong. He couldn't figure out if it was because he was importing the wrong name or if it wasn't in path. And he started futzing around with, are these in the right path? And the path seemed fine to him. And he, added all sorts of paths in all sorts of formats just to get them to work. But the underlying problem was it was just using the wrong executable. There's also another very useful trick, which is, I had this happen to me as well. You have a module, and that module has some code. And you need to figure out, or you don't maybe trust the documentation that is provided with the module, if any is provided at all. So you need to read the code. And you need to find where that code is. And as you know, this code could be pretty much anywhere in any of the paths provided by sys.path. Additionally, if you look in those paths, you may find many different versions of that same module. So you want to figure out, when I import this module, what is the code that's actually running? Well, if you take a module object and you look at the underscore file underscore attributes, you'll be able to see this is the actual file that's running. And this is a nice way to figure out where's the code that I want to read to figure out what this module is really doing. I've done this or I've had to do this many times. So sys.metapath we will talk about in great depth, in exhaustive depth. Path hooks as well. Actually, we'll talk about path hooks. We probably won't talk about path hooks. The next thing, sys.path. This is maybe a strategy for debugging some code. So say you're at an intermediate level. You've thrown together a couple of administrative scripts. You've glued some code together. You're using Python just as a means to an end to get some larger system working. It's not the sole focus of your job. And for some reason, you have a module, and that module has some bug in it. Or maybe one file in that module has some bug in it. And your options are, maybe you need to file a bug report and wait for the developers of that module to get back to you, which we all know may or may not ever happen. Or maybe you're on Red Hat Enterprise Linux, and so all of your packages are from the late 90s, early 2000s, because for some reason stability means never updating a package in the last 8 years. So the version of the module that you have was written sometime after cuneiform became the standard alphabet, and the version of the module you need was written maybe 1 or 2 years ago. So what are you going to do? Are you going to work around your package manager? You're going to install this module with possibly all of its dependencies manually somewhere, and perhaps screw up the very careful package management that you've been, package management strategy you've been employing on the server. Or alternatively, maybe you can put the module that you really want somewhere in some controlled directory and alter sys.path. So what sys.path is it's a list of paths where the Python interpreter will try to find modules for import. And that's all it is. So when you do something like import collections or import default dict, it'll look in sys.path until it can find an appropriate default dict or collections file or directory or zip file or egg to import. And if you put a file called collections.py or defaultdict.py in one of the paths towards the front of that list, that's what's going to get imported instead. So this is a very simple trick that you can use to maybe work around some buggy code. You make your small fix, you put it somewhere in sys.path, you leave the original module intact because your fix may have wider changes than just your app, especially if the buggy module is in your system Python. Because who knows what other tools like apt might be relying on this module, and they may have their own workarounds, and your workaround may conflict with theirs. So this is a way that you can localize the change in a controlled fashion. Most of the contents of this talk are really about how do you, when I talk about workarounds, I think the main focus is how do you localize the changes in a controlled fashion. Because we can all, when I gave this talk the first time, a lot of people asked, why don't you just tell the maintainer of that module to fix it? Well, we should be a little bit realistic here. I mean, that's the right thing to do, and we should do that. But their timetable and our timetable may not be the same. Similarly, you might ask, why not just make your change and then test everything? And at the same time, testing everything may not be within the purview of what we need to do for our organization today. And it may take an enormous amount of time and resources away from our sole goal, which is saving the whales or who knows what, if the Saving the Whales organization uses Python, which they probably do because Python sounds very environmental. And it has a garbage collector, so they like that too. OK, so the way to alter sys.path, there's pretty much 3 ways to do it. From sys import path, you can append things to the end of it. You can import sys and do sys.path equals something new. I had a discussion with John in the back about this earlier, or yesterday. And basically, if you do sys.path, if you do import sys and do sys.path equals something, that's great. The path variable is module scope or global in the sys module, and you want to overwrite it. So this first example is fine. You're adding home user my modules to the front of sys.path. The append method on a list mutates in place. So the second example, from sys import path, path.append, is fine too. You're appending something to the end. Similarly, you can use the whole qualified path. The one thing, and this is meaningful for some examples I give later, you cannot do, oops, you can do that. You can't do this. This is importing, so let's really think about what this does. From sys import path, it goes into the sys module, which may already be loaded, and if it's already loaded, it pulls it out of a dictionary sys.modules. Sys.modules is a dictionary of name to module object for every module that's imported in the current running interpreter. So it'll go into there, and it'll do an attribute lookup on the sys module to get whatever path is. Then it'll assign path to a local variable or a variable in whatever scope you're in. And since path here is a reference to some list, then now path is a reference to some list. When you reassign it, you're reassigning that local, which means that this line here will have no change to the actual path variable you want to affect. This is just going to create a shadowed path variable in your local or in your module scope that will have no effect beyond, it'll have no effect on anything. Because when the import mechanism is triggered, it'll look at explicitly sys.path, not whatever path is in scope at the time. Mm-hmm. 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 Exactly. So the next really neat thing, this is something I use all the time, code.interactive console. Nobody seems to know about this. I think some people know about PDB. PDB is a module in the standard module. There's pdb.setTrace, and it pops you into a PDB debugger anywhere in your code. And that can be useful, but for those of us who may not have memorized the single-letter GDB commands, having an actual Python interpreter at some arbitrary point in your code can be very useful. That's what code.interactive console does. So all you do is so say I have some script, hello world, oops, there. So I have some script, and it does some code above, and it does some code below, and we'll ignore these two lines temporarily. Interactive console will just dump the running interpreter into an interactive console, which in this case will allow you to inspect all of the local variables in that state. Very, very useful. And it'll work anywhere where you have access to a console and an interpreter. So for example, I was debugging a Django view. And in the Django view, I stuck this little piece of code. And the moment somebody reloaded that page, this was in test, this obviously wasn't in production, but the moment somebody reloaded that page, Django screeched to a halt. I got an interactive console. I could look at everything in scope. I could see all the variables that were passed to it. I could modify those if I didn't pass a copy of it. And then I could continue execution. Now, from a page loading perspective, the page load halted the moment I hit an interactive console. Because you can think Django is also halted here. And when I Control-D out of that interactive console, then the page continues its loading. If you want to get a little bit fancy, you can add these two lines, which I also frequently do, which means when you're creating that interactive console, you've now given it read line support and tab completion. So just to belabor this example, right? Oh. Okay. So I have to write this somewhere. Okay, so, and I can see all the variables in scope, only A, B, and C. The way I've set up this interactive console, I've shadowed these, so if I make changes, they won't get reflected. But when I Control-D, you can see execution resumed, just as normal. And I also have read line support here, so I could do, well, unfortunately, my variable names are a single character long, so I can't show you tab completion. Let me address that. Yeah? What do you mean? In a function? Like that? Yeah, you can put them anywhere. So notice I just ran this, and that function wasn't called, so nothing happened. And then I'll put that in there, and then bam. You can put it anywhere. You could put it in at the top of a module that's loaded. You could put it in a function. You could put it. The one tricky thing is if you have multiple threads running, or if you don't have some console for it to pop open the interactive console. If you are for some reason running Python, maybe embedded in a larger application, and you don't have the standard out of that Python interpreter connected to somewhere meaningful, and that standard in of that Python interpreter connected to somewhere meaningful, and you try this, what will probably happen is your application will grind to a halt, And because nobody can terminate that console that you've popped up, you just have to kill the application. But for most cases of applications that we build, on Linux running straight out of a regular Python interpreter, it'll just work. You put it anywhere, and the moment those lines execute, bam. You get a regular Python console. You can do regular Python things with it, which means you can import modules. You can do you have a console that is running within that code. And also, you could think that maybe if you wanted to have a really cool application, you might even be able to build a little application around this, where the application does all of its magic outside of that and just pops into interactive console. In your interactive console, you control the application in some fashion. Of course, there's a better way to do that. There's a CMD module in the standard library that allows you to build really nice command line applications. But I mean, there's a lot of things you can do with it. It's a little bit better than PDB in that respect. You can't set breakpoints, obviously. It's also a little bit simpler than PDB because you don't have to learn all the PDB verbs. So I think for a beginner or intermediate user, it's actually a really useful little trick that you can have just to be able to get a point where you can inspect what's happening in your code. In the absence of a real debugger like PUDB or something built into Eclipse or PDB or who knows what, and in the absence of any other debugging tool. Oh, this one's a really simple one. Python-v-v. Just run Python in verbose mode. It'll print out everything that's importing. It'll print out, I think actually it just prints out everything that goes through the import mechanism. And it prints out some cleanup and garbage collection information. So it's very useful if you have a small application, you need to figure out what's being imported from where and is everything getting cleaned up. OK, so the next one is modifying modules. This is the example I gave you before. So here, I have a very simple little class. And this class uses the logging module, and it inherits from a standard dictionary, and it just overloads the standard items from that dictionary. Get item. I didn't do set item because this is just around pulling things out. So get item, get set default, pop item, anything that pulls a value out of that dictionary, it's wrapping. And it's wrapping with just a logging statement to say what got pulled out, under what key. So you could think, why would this be useful? Well, it turns out that in the OS module, there's a dictionary called environ, which gives you all the environmental variables that are provided to the interpreter. So say you have, and I've seen this many times, say you have some Python script that runs after a series of bash scripts that set up all sorts of crazy environmental variables. And if you, at the very end of that chain, if you type set and see what environmental variables are out there, or env, see what environmental variables are out there, it'll be 2 or 3 pages long. And how many of those are actually even used, or does anyone even care about anymore? It's unclear. With this, if you added this at the entrance point of your application and then let it run for as long as it needed to run, it would log for you every time the application tried to read an environmental variable. If you wanted to make this a richer example, you could also check to see if it ever tried to set an environmental variable. But you could see exactly what environmental variables were necessary. I actually used this in production to be able to write a simpler shim in the place of a couple of batch scripts to actually get a Python interpreter that had all of the paths set up to run an application. So it's a neat little tool. Now, this also illustrates another very cool technique, which is you can replace things in the standard modules, right? So environ used to be a regular environment. It used to be a regular dictionary. I just wholesale replaced it with my own wrapped version of it. Or I actually copied it into a proxy object. Or not even a proxy object, just copied into a new dictionary class object, and then went on. And I saved it somewhere just in case I need the original environment later, which is probably a pretty good idea. Of course, you can think that this is actually, what you'd really want to do is you'd want to save it into some sort of stack, because who knows how many times people have written their own, how many times in your gigantic code base people have replaced environment with something else, and down the line, as you replace these items, you'd want to replace them with whatever you replaced. So I'm not sure if that made any sense, but the idea is that you're not the only one who might be modifying these standard modules, especially not if I'm at your company, because you definitely could. Actually, that's a very, very good point. You could easily have a context manager to. That's a fantastic idea. Yes, I will. Okay, so now we're getting into import hooks. Python has a lot of neat little features here and there. I think one thing that makes Python a very nice engineering language is that a lot of the internals of the language are exposed in a consistent and usable fashion. So we looked at the sys module, and the sys module exposes a lot of the internals for how the interpreter works. There's an actual sys.modules object that tells you all the modules that are imported. You can actually manipulate that. You can remove things from sys.modules, and that's similar to, well, it's probably something you shouldn't do, but you can load things into sys.modules, which you also probably shouldn't do. But you actually can do it, and you can do it in a controlled fashion. Similarly, there's a GC module. Some time ago, I had to figure out why an application was having some memory issues, and I could see using the GC modules all the objects that were live, all the objects that were dead, which objects were getting collected and which weren't getting collected. You can see that the standard library provides you with a lot of very useful primitives for analyzing a running program, for interacting with the interpreter in a controlled and robust fashion. Import hooks are yet another one of these mechanisms. So when you import a module, maybe you want to hook that process. Maybe you want to do something slightly different, right? Back in the day, this was accomplished by overloading this _import_ function in built-ins. And that was a function that was called whenever you did an import. And the mechanism was a little bit sloppy. So it was replaced fairly recently, within the last few years, with a more standardized, more robust mechanism that is formed out of import hooks and path hooks. I'm not going to talk about path hooks, but essentially path hooks are a way for you to, in your sys.path, add paths which may not be physical paths on the system. So if any of you ever use zip import, in zip import you add a zip file to your sys.path, and then when the interpreter asks to see, does this path contain the module I'm trying to import, zip import will step in and will look through the contents of that zip file for the module that you want. Similarly, you could, if you wanted to, write a path hook wherein in sys.path you could add URLs, and that path hook would then query that URL and download the code if necessary. You probably shouldn't do that because it would be somewhat potentially insecure, but you could if you wanted to. So I'll very briefly go over how the mechanism works, and then we'll look at some really neat examples. So this is a simple logging hook. It's not that simple because I have comments. Well, we'll look at these two parts. These are the only really meaningful parts. The protocol that we care about for import hooks consists of two functions, find module and load module. So essentially, you create an object. You add that object to sys.metapath. When you try and import a module, the importing mechanism will go down the line and query each object with this find module call. It'll say, I'm looking for a module called RE. Can you import that module? And the import hook will respond, yes, I can import it, or no, I can't. If it can import the module, then the import mechanism will say, OK, I'll call load module on you with the name of the package I want to import, and then please handle the import. If it can't, then it just keeps going down the line. Now, import hooks, I think, are only really powerful, or we could only really consider a very powerful and robust tool within the context of two libraries in the standard library, the IMP library and the import lib library. Because you could think that you might want an import hook that doesn't handle the import entirely. You might want an import hook that just does something small on top of the regular import mechanism. In this example, all it does is log, I tried to import this module. In order to do that robustly, you need to have some way to pass the buck. You need to have some way to get in, do your thing, and then pass the importing of this module down the line and let the regular mechanism take over again. Because if you try to simulate the regular mechanism, and maybe they change the regular mechanism, or you miss some tiny detail, then your import hook would start to subtly change the semantics of the program. So here, all I do is I log that I found the module. I actually need to make sure that this import hook doesn't get triggered twice, because when I try and load the module, I ask the regular import mechanism, can you load this module? And by capturing if I've seen the module yet, the next time the regular import mechanism tries to load this module, my import hook will say, I don't know what you're talking about. I've never heard of that thing before. And it'll go down the line and hit the actual tool that can import it. That's the pattern to a lot of the import hooks that I have in this talk. Namely, you do a little bit of processing. Or rather, you respond that you can import the file. You do a little bit of processing. You mark that you've seen this, that the import mechanism has asked you to import this file. And then you pass it off to, you say, I can import this. I'll take care of it. In your load module, you do a little bit of work. Then you ask the regular import mechanism, can you import this file myself? The process starts all over again from the beginning. But this time, when the import mechanism asks you, can you import this file? You say, nope, I don't know what you're talking about. And the import continues on to where it was supposed to actually hit. And that's what this guy does. So I'll show you an example of how this works. So I have a slightly more advanced version of that hook here. And this is a hook which, when it imports, it puts, instead of logging it, it puts it into a dictionary that encodes a tree. So if some module tries to import another module, it'll just build a tree of what imports what. And then I have a very simple generator somewhere this guy. I have a very simple generator here that recurses through that dictionary to build a graphviz dot file. Pretty simple stuff. So if I run this file adds the import hook, then it imports a bunch of modules that I know to be pretty big. Func tools, iter tools, collection, operator, AST, some XML stuff, and so forth and so on. And it just prints out the dot file. So if I run this, print out the dot file. So you can see logging imports time, random imports an underscore random, so probably some of this has been implemented in C. It also imports hashlib. It also has a future. I wonder what that's for. It also imports bin ASCII and math. And with that dot file, I can produce a graphviz file, or I can produce a graph. And so I'll show that to you. Let's see, where is it? Oh, do I not have the PS file here? OK. So I can produce this. So that is a graph of everything that my little sample program tried to import. There's a little bug in this that I've been meaning to fix for a long time. This is slow scrolling. But you can see we start from our main, and we imported random, and random imported underscore random, hashlib, future, bin ASCII, so forth and so on. I think this is really cool. I think this is actually really, really cool. Because you could think if you had an application and you didn't really know what was going on, what was importing what, how it worked, you could use something like this to very nicely step in, observe what's going on. The system doesn't have to know about anything, right? Like this application has not had its runtime semantics at all altered by the introduction of this import hook. It just works. And at the same time, I'm just capturing some very useful information which I can graph and then use for my own purposes, namely for analyzing how this application works. Is anyone else as excited as I am? OK. Oh, absolutely. It would be very easy. And then Mm-hmm. Exactly, exactly. You could add a lot of information there to figure out, what's really going on. Okay. Okay, so here's another thing that I actually had to use. What was it called? It was called diff import. No, it was called import. I have to remember which file it was, because diff import is something really crazy. Oh, subhook? Oh yeah, subhook, yes. So subhook is a really simple import hook. And what it does is, I had a Django project using PyMongo. And there was an upgrade to PyMongo where they moved a module from one place to another. They had like I think it was a bson module, and it used to be just from PyMongo import bson. I don't know if I'm remembering the details exactly, but it used to be in the root level, and they moved it down one level. And there were about 15 files that did this import. And I was just trying to get this to run because somebody was trying to show me something about this code. They said, oh, no worries, I'll just write a sed script, and I'll just replace all the from whatever import bson with from whatever dot whatever import bson, and we'll get going. But you could think this is a little bit dangerous to do, because you'd have to set it back when you're done, and you also might not be able to capture all of those points. And there's many reasons why you might not want to adjust the way that a running application works. So here I have an import hook that, when you create the import hook, you set a bunch of overrides, right? So what I did was I created an import sub hook, and whenever you try and import bad module, it'll, in its place, import the math module. And so every time you do an import bad module, it'll just import the math module instead. And you can redirect imports in this fashion. I think that's really cool. You could think this would be a really neat way to debug some tool, because say you have code that was written by some other guys, and they use a very slow module everywhere, and you want to rewrite some tiny part of this module to be really fast. But you don't have to go into all their code and change all their imports to import my math, right? What you could do is you could write an import hook that every time it sees their import, it redirects to your code instead, and their code doesn't have to know about this at all. And it'll just work transparently and robustly. It'll just work. And then you can get in whatever module you want. Similarly, if you had some code and you wanted to subvert its normal course of operations, you could, at the same time, without the rest of the code knowing, just redirect the imports that it uses. So maybe you have some library that you don't have the ability to change, and you know that it does some regular expression matching, so it imports the RE module. You could just possibly have it so that it imported the RE module, but all the things in the RE module were actually stuff that you had written that in some way match things in a different way. Or maybe it imports the get pass module to get the user's pass. And maybe you thought for some reason it might make sense for you to email the pass that was entered at the command line to your email address for debugging purposes. Who knows, right? So you could do that, and the rest of the code base would not have to know about it. The one limitation here is, as you can see, you need to get an import hook in at the starting point of the application before anyone else does their inputs, because there's a sequence to the operations that are done here. So here I had to get the import hook in first, and then everything following that the import mechanism would be able to use my import hook following that. So you'd have to be able to inject that code there. Now, one thing that you can see that's a limitation here is you create your import hook. You insert it into sys.metapath. Then every import that happens after that follows or can be affected by this import hook. So say you have a module that you need to distribute to people in the form of a single Python file. And for some reason, there is some part of that you want to be affected by you need to customize the import mechanism for that, right? For the import of your module. Think about it. You'll have to then say, OK, I'm giving you this file. And when you use this file, you first need to do import sys.metapath.append, blah, blah, blah. Then import my file. Can you do necessarily want to add that additional processing step? No. So there's a limitation here. But I have an example of an import hook that is self-contained. This took me a little bit of time to come up with, and I think it is really, really cool. So here we have an import hook that is totally self-contained. What this means is, when you import this module, you can actually see what happens. It's very simple. Actually, I may have an even better example of this. Let's see, I have an even more robust version of this. Oh, yes, this is actually the proper one. OK, so this I thought this was just really, really neat. OK, so your code's chugging along happily. It tries to import this module. You have this standard preamble, if name equals main, right? We don't want to trigger this if you're running this as a script. We want to trigger this if you're running this as a module. So I have if name doesn't equal main. So when you're trying to import this as a module, what you do is you import sys.metapath. You import module from the import lib, which is your hook into the actual import mechanism itself. You add in the hook that you have. Then you force a reload of yourself. Isn't that cool? You force the import mechanism to reload yourself. And because you haven't been loaded yet, the import mechanism will happily reload yourself. Upon that reload, it'll trigger your import hook. And then in the load module, you just delete the old guy out of sys.modules and replace it with yourself. So in this way, you can actually have an import hook that's self-contained in a single file, which means that people, if they don't look inside what's happening inside that file, they can be blissfully unaware of any sort of shenanigans that you are doing in your import hook. So you could do this for all sorts of really crazy stuff, right? In this example, I have this. So this is just a string, right? Nothing happens. It's just a simple string. No magic whatsoever. If I import this module, what do you think the value of x will be? Now, of course, you can probably tell what it is because this is a contrived example. But what should it be? There's only one declaration of x at the 10. It should be 10, right? Very simple. So let's see. What happens when I import this? What? Let's take a look at that file one more time. It should be this, right? Because this is just a string. No, my import hook identifies my own file, does a regular expression substitution, or actually does a regular substitution on that file. Then it evaluates itself and then continues down the line. Which means this thing here could be, some regular Python code. But if I wanted to, and if I had the time to put the mechanism together, I could do something like, I could put some Perl code here. And then I could have the import hook pass some stuff off to Perl using os.system or some sort of subprocess, pull that stuff back in, maybe a Perl code that writes, maybe a bit of Perl code that writes some Python code, and then just stick it right back into the module. And the really cool thing is, because this is self-contained, anyone importing your module doesn't have to know that it even exists. So you could think, potentially, if you had a module that only exported data, that didn't export any sort of functions, you could, if you wanted to, write that module in Perl, encode all the Perl in your Python file, have the Perl just export statements like x equals blah, 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 y equals list of blah, 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 and then have a little Python file that's actually a Perl file, and people importing it will have no idea what you're doing. That would be really cool. It would be terrible, but it would be cool. And sometimes we need a little terror in our lives. I'll show you another example of some craziness. OK, so we'll look at diff import. Diff import. This is my favorite. It's a little bit tricky, and probably this is not the name I should have given this module within it, but it does require a little sneaky module in it. And the sneaky module itself is surprisingly clever. The sneaky module is actually like a module proxy object. It's really, really dodgy. But I'll show you the effect of it, because I think we're running out of time. And I think y'all would really appreciate the effect of this thing. OK, so we have two files. Can anyone spot the difference in these two files? I'm just tabbing between the two. Can anyone spot the difference in these two files? It's actually a trick question. There is no difference, right? These files are identical. So the files are identical. Do you think the output is identical? I mean, obviously, no, it's not going to be, but just come on, play along. So if I did, Python, white clever bird, and yellow sad dog, they are not identical. The two files are doing totally different things. Let's try that again. OK, let's do this. Green, happy pony. Should that ever happen? Honestly, should that ever happen? Should you move a file and suddenly its output changes? What's happening here is that import hook is using the inspect module to climb up a few stack frames and figure out what's the name of the guy who's trying to import me. Then it parses that name, and it changes its own contents based off of what's trying to import it. This is incredibly sneaky. But you could think, you could actually use this. You could actually honestly use this. Say the two files that are importing your one file, one of them works correctly and one of them has a bug. And you want to pass a little bit of code to one of them that's different from the code you pass to the other one. You could discriminate based off of who's importing you what code you pass to them. And you could do it using an import hook in this mechanism, in this way. I think that is really, really cool. It shows the power of Python. Notice that these examples were no more than, even the trickiest of these examples, were no more than 50 lines long. So you can, with a little bit of code, write a very robust, very tricky piece of magic that substantially that can assist. I should cast this the other way. That can assist in your debugging attempts or your attempts to work around a system that may have some issues with it, and it'll just work. It'll just work. You can put it into production. It doesn't have any problems. Of course, don't ever do this, and don't ever put it into production, because if you do put it into production, it'll break. But if you know what you're doing, which you probably don't, because I don't know what I'm doing either, don't do it. But anyway, I think it's really cool to at least play around with it. So I hope you enjoyed this import hooks, code recipes for debugging. Please let me know if you have any questions.